In this session, we'll dive deeper into polarity testing by focusing on Test 1, which checks the supply voltage between the active and neutral wires. Place the probes of your voltmeter between the active and neutral points. Check the voltage reading. Normally, you should see a voltage of 230 volts. In scenario 1, the voltmeter shows 76.67 volts. In scenario 2, the voltmeter shows 76.67 volts. In scenario 3, the voltmeter shows 76.67 volts. When the voltage is lower than 230 volts, like in these scenarios, it can indicate one of the following issues. The supply from the transformer is less than the nominal voltage. The active circuit has high impedance or an open circuit. The neutral circuit has high impedance or an open circuit. In our tests, we toggle the voltmeter between high impedance, high Z, and low impedance, low Z settings. This helps us detect a phantom voltage, which occurs when there's a break or high impedance in the circuit. In scenario 1, when we switch to low Z, the voltage hardly changes. This means the voltage reading is real and can supply a high current. The test confirms that the resistances in the circuit are good, but the transformer is supplying only 76.67 volts, which is lower than expected. In scenario 2, we measure 76.67 volts between the active and neutral wires. Let's analyze this using the low Z setting on the voltmeter. When we toggle to low Z, the voltage drops to nearly 0 volts. This indicates the presence of phantom voltage, meaning those high impedance between the active and neutral lines. Next, we test between the active node and an independent earth. The reading shows 230 volts. When toggling to low Z, the voltage only drops slightly, confirming that the 230 volts is real and can supply high current to the active line. Now, we test between the neutral node and the independent earth. The voltmeter reads 76.67 volts. When toggling to low Z, the voltage drops to a very low value, confirming phantom voltage or high resistance in the neutral circuit. By reviewing the component values, we can see that the supply is at 230 volts, but there's high resistance, 10 megaohms, across the neutral supply cable, RCN. In scenario 3, we again measure 76.67 volts. Let's break it down. Low Z toggle. The voltage drops to near 0 volts, signaling phantom voltage due to high impedance in the active or neutral line. We then place the probes between the active node and the independent earth. The reading shows 76.67 volts. After switching to low Z, the voltage drops significantly, confirming phantom voltage or high resistance in the active circuit. Lastly, we test between the neutral node and the independent earth. The voltmeter reads 0 volts, which is expected voltage. Since there is no voltage, this indicates there is no phantom voltage in the neutral circuit. Upon inspecting component values, we find that the supply is at 230 volts, but there's a high resistance, 10 megaohms, across the fuse IF in the consumer active circuit. These scenarios highlight how high impedance or phantom voltage can be detected and diagnosed using proper testing techniques.